Hello and welcome back to the deep dive. I want you to just, for a second, picture a really common moment in your day.
Okay.
You're at your desk, you've got your coffee, you open up your laptop, and you see that little notification, the little badge, the one updates available.
The little red dot, the one that you just have to click.
Exactly. And if you're a responsible user or even just someone who hates those red dots, you click update all.
Mm-hmm.
It's just muscle memory at this point.
Well, we've been trained for it. For 20 years, the message has been, updates are good. Updates are safe.
Right. They mean security patches, new features. They mean you're doing the right thing.
It's basically the social contract of software. You trust the vendor, and they deliver the fix. It's supposed to be the one safe action you can take online.
Well, today we are going to look at a story that just completely shreds that contract. We're looking at an incident from early February 2026 that turns that whole idea on its head. This is a supply chain attack that didn't happen because someone fell for a phishing email. It happened because thousands of developers did exactly what they were supposed to do.
They updated their tool.
They updated their trusted tools.
And that is the nightmare scenario. We're talking about the GlassWorm malware incident that hit the open VSX registry. And this isn't just another, virus found headline. The mechanics of this are, well, they're frankly on another level.
Okay, so the Open VSX registry, just to set the stage for everyone, that's the marketplace for extensions for tools like VS Code, right?
Exactly. It's an open source alternative to Microsoft's official one.
Yeah.
A huge hub for developers to grab tools that make their jobs easier.
So our mission today is to dig into how this malware, GlassWorm, got into that ecosystem. But I think what's more important, what I really want to understand, is how it stayed hidden.
Mm-hmm.
Because I was reading the report, and this thing was apparently using the Solana blockchain to hide its instructions. I mean, it sounds like something out of a sci-fi novel.
It really does. But before we get to the cyberpunk tech, we have to talk about the social engineering part of it.
Yeah.
Because that's really where the betrayal begins.
Usually when we cover these, we talk about typo squatting. I go to download code helper, but I accidentally download C0D helper with a 0.
Right. It relies on user error. You're in a rush. You don't look closely. But GlassWorm didn't do that. The attackers didn't make a fake account.
They compromised a real one.
A real one.
The account was Ors. And this wasn't some, burner account made last week.
No, and that is the absolutely terrifying part.
Yeah.
Orsa was a legitimate developer. They had been active on the marketplace for over 2 years.
2 years.
2 years. Published multiple extensions. By the time the attack happened, those extensions had been downloaded over 22,000 times.
Wow. Okay, so that's a huge amount of implicit trust right there. If I downloaded a tool from this developer in 2024 and it's been working fine,
you have absolutely no reason to suspect it in 2026. You've probably forgotten the author's name. You just know the tool works.
Yeah.
So when that update available notification pops up, you don't hesitate.
You just click yes. So what were these tools? Were they, high-risk security apps or something?
The exact opposite. They were incredibly mundane. Let's see, I have the list here. One was Strush tools for syncing files. Another was for translation management. There was a mind mapping tool.
Okay.
And a SCSS to CSS compiler.
A CSS compiler. That is the most background noise piece of software I can imagine.
It's perfect, isn't it?
You install it once, it just runs when you save a file, and you never think about it again.
Which makes it the perfect carrier. It has a reason to be active, a reason to access your files. It's the perfect camouflage.
So on January 30th, 2026, the attackers who control this account push an update. 22,000 developers pull it down. What happens then?
Well, it's not a skull and crossbones on the screen, I can tell you that. The update contains something called the GlassWorm loader. And this is where the technical side gets really, really sophisticated.
The loader isn't the virus itself?
No, think of it as the delivery mechanism, a Trojan horse. The malicious code inside the extension is encrypted.
Ah.
So if your antivirus scans the file on your hard drive, it just looks like a bunch of random data. It doesn't match any known virus signatures.
Or it gets a green light.
Exactly. It only decrypts itself. It only unpacks the weapon when the program is actually running in memory.
And once it's unpacked, it needs orders, right? It needs to phone home to a command and control server somewhere.
Yes. And normally that's where defenders have a chance. We look for that weird connection to a suspicious IP address, and we block it. We cut the line.
But GlassWorm didn't do that.
No. It used a technique that researchers are calling EtherHiding.
EtherHiding. It sounds cool. I'll give them that. What does it actually do?
It means they don't use a server. They use the Solana blockchain.
Okay, you have to unpack that for me. How do you use a crypto ledger to control malware?
Well, blockchains are public ledgers, right? Anyone can read them. And on Solana, when you make a transaction, you can attach a little piece of text, a memo.
Right, for notes, like for lunch or something.
Exactly. But the attackers aren't buying coffee. They're posting encrypted instructions in those memos.
No way.
Yes. The malware on an infected computer is programmed to just watch the blockchain. It looks for transactions from a specific wallet address, and when it sees one, it reads the memo.
That's genius, because you can't block Solana.
You can't. Think about it. If you're a network admin at a tech company, you can't just block all traffic to Solana's API. You'd break legitimate crypto apps, maybe even some of your own company's tools. It's too big to block.
And for the attackers, it's a dead drop. They don't need to maintain a server that could get taken down. They just send a tiny transaction, and every infected machine in the world gets new orders instantly.
It makes their infrastructure incredibly resilient. There's no server to take down. There's just the blockchain, which is immutable and distributed across the entire globe.
So the malware wakes up, it checks the blockchain for its orders, and it gets the green light. But the report mentioned a catch. There's a specific check it runs first.
Yes, the safety check, or as some are calling it, the Russian shield. Before GlassWorm does anything, it profiles the machine. It checks the system locale.
So it checks what language your computer is set to.
Essentially, yes. If the system locale is Russian or Ukrainian or Belarusian, basically from that region, the malware creates an exclusion file for itself and just shuts down. It refuses to detonate.
We've seen this before. It's not a bug, it's a feature. It's a geopolitical tactic.
It's a get-out-of-jail-free card. The unspoken rule for cybercriminals in that jurisdiction is don't make a mess in your own backyard. If you hack an American company, local authorities might look the other way.
But if you hack a local business, you get a knock on the door.
It is 100% self-preservation, and it strongly suggests the threat actors are Russian-speaking and operating from within that region.
Okay, so let's say I'm not in that region. I'm a developer in Berlin or Toronto. I've updated my CSS compiler. GlassWorm is active. It's checked Solana. It's ready to go. What's it looking for?
It starts with the Brug sweep, the smash and grab. It goes through your browsers, Chrome, Firefox, you name it. It's looking for saved passwords, session cookies, browsing history.
The session cookies are the really scary part, right? They don't even need my password at that point.
Often, no. If you have a Remember Me session active, the cookie is the key. They just copy the key and they're in. It also grabs documents from your desktop and downloads folders. And it specifically targets crypto wallets.
Which ones?
MetaMask, Exodus, Ledger Live, Trezor, Binance, Tonkeeper. A pretty comprehensive list.
Okay, so that's bad. But you said this was a new level of sophistication? Stealing crypto wallets feels kind of standard for malware these days?
It is. But that's just the opening act. This isn't about stealing $50 in Bitcoin. GlassWorm was built to hunt for developer credentials.
Oh.
It has specific routines to find and steal the contents of your .as folder and your .as folder.
Let's pause on that, because for a non-technical listener, .as just sounds like a random folder. Why is that the holy grail?
If you work with Amazon Web Services, that folder on your laptop contains your credentials, the access keys, the literal keys to your company's cloud kingdom.
So if I work at a major online retailer, those keys could potentially let an attacker access everything. Customer databases, servers.
Everything. In many configurations, those keys grant administrative access, and the .ash folder contains the private keys used to log directly into those servers.
So they aren't just robbing the developer's house, they're using the developer's keys to get into the corporate office.
That's the textbook definition of lateral movement. You infect the developer's laptop, and you ride their credentials straight into the company's production environment, their cloud infrastructure, their private code repositories.
Which brings us to GitHub. The report says it looks for those tokens, too.
It does, which means they can steal private source code. Or, even worse, they could use those credentials to secretly modify the company's own products.
And inject GlassWorm into something else.
It's a viral loop. It's how a small infection on one developer's machine can become a global supply chain nightmare.
This whole situation really highlights the fragility of the trust we place in this system.
It does. And that trust is hard to undo, even when we know something is wrong. Which brings us to the persistence problem.
Right, the catch-22 of getting rid of it. So the attack is discovered. On February 2nd, the Open VSX admins take down the compromised extensions. Problem solved, right?
You would think so. But it's not like an iPhone, where Apple can sometimes remotely kill a bad app. Removing an extension from the marketplace only stops new people from downloading it.
So if I already have it...
It's still there. It's still running. It's still checking Solana for orders and stealing your keys.
But can't someone just push a clean update to overwrite the bad one?
Well, who would push it? The original developer's account, URIX, is compromised, and the marketplace admins have, correctly, banned that account.
So no one can push a new version?
No one. The only way to get rid of this thing is for you, the user, to manually go into your extension list, find these specific tools, and click uninstall.
But if I'm not obsessively following cybersecurity news, I would have no idea I need to do that.
And that's the danger. There are probably thousands of machines out there right now still running that malicious mind mapping tool, still compromised because the user has no idea they need to manually intervene.
It's a zombie extension, dead on the marketplace, but alive and well on your machine.
Exactly.
So let's get practical. If I'm listening right now and I'm a developer, what should I do?
First thing, an immediate audit. Go into your editor, check every single installed extension, specifically search for anything published by the author URIX.
And if you find one?
Uninstall it immediately. But you can't stop there. You have to operate under the assumption that if that extension was on your machine after late January, your credentials have been compromised.
Rotate everything.
Everything. New AWS keys. New SSH keys, revoke your GitHub tokens, change your passwords. It's a huge pain, I know. But the alternative is leaving a backdoor wide open into your entire corporate infrastructure.
It really feels like we're at a breaking point. We can't just keep blindly clicking update all.
We can't. The whole industry is moving towards a zero-trust model,
Right.
And that has to apply to our development tools, too. We need security that doesn't just check the signature on a file. It needs to watch what the file does.
Behavioral analysis.
Right. We need a system that flags behavior and says, hang on, why is a CSS compiler trying to read the Solana blockchain? That makes no sense.
That's a great analogy. It's like if your plumber, who you trust, suddenly asks for your bank password. It doesn't matter who they are. The request itself is the red flag.
Perfect. Right now, most of our security is just checking the plumber's ID badge. It sees a valid badge and lets them in. It's not watching to see if they start pocketing the serverware.
And until the tools get smarter, we have to be the ones watching.
We have to. And we have to be better about digital hygiene. If you installed an extension 6 months ago and haven't used it, just delete it. Every line of code on your machine is a potential liability.
Sobering thought. We treat these tools like utilities, but they're doorways.
They are. And GlassWorm proved that even the most boring, trusted doorway can be turned into a weapon overnight.
Before we go, I want to leave everyone with one last thought on this. We've talked about the tech, the tactics. What's the big picture takeaway?
I would just ask you this. If a trusted tool you've used for 2 years silently updated itself into malware this morning, would you even know? And more importantly, would your security tools notice it looking at a cryptocurrency ledger for its orders before it stole your company's cloud keys?
Because for most people, the answer to that is probably no.
For the vast majority of companies, the answer is no. And that's the gap we have to close.
Go check your extensions. Seriously. Pause this and go do it right now.
Stay safe.
Thanks for listening to The Deep Dive. We'll see you next time.